When x is equal to 0, probability value is distribution x is equal to P of x is equal to 0 is 125 by 216. So when x is equal to 0, P of 0 is 0.1. When x is equal to 1, it is k. When x is equal to 2, it is 2k. K and 2k. First ball will be the red and the second will be the black, and the last condition is both the black balls you may get. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed regarding the probability distributions and few problems based on the probability distribution. Today, I am going to take few more problems based on probability distribution. Now, let us straight away come to the problem. Now, so in probability distribution, find the probability distribution of number of doublets in 3 throws of a pair of dice. If a pair of dice are thrown, 3 throws, a pair of dice, what is the probability distribution of getting doublets? Now, doublets means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. Now, here let x denote the number of doublets. The number of doublets are, the possible events are 1, 1. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. Now listen to me. So clearly x can take the value 0, 1, 2 or 3. Now the probability of getting a doublet. So there are how many possibilities? 1, 2, 3, 4, 5 and 6. 6 divided by the total number of events are 36. So this is equal to 1 by 6. The probability of getting a doublet is 1 by 6. Now the probability of not getting a doublet is 1 minus 1 by 6. Take LCM, 6 is LCM, 6 minus 1 is 5 by 6. So the probability of getting a doublet is 1 by 6 and the probability of not getting a doublet is 5 by 6. Okay, listen to me. Let x denotes the number of doublet. The possible doublets are equal 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. Now clearly x can take the values 0 or 1, 2 or 3. X can take the value 0, 1, 2 or 3. So the probability of getting a doublet is 6. There are 6 events, 6 divided by 36, that's equal to 1 by 6. And probability of not getting a doublet is 1 minus 1 by 6. That is 1 minus P of x, that is 1 minus 1 by 6 is 6 minus 1 by 6 is equal to 5 by 6. Okay. So what is required to find is the probability distribution of number of doublets in 3 throws. So we are using 3 throws. Therefore, probability of not getting a doublet is probability of x is equal to 0. That is probability of not getting a doublet is 3 times 5 by 6 into 5 by 6 into 5 by 6. That is equal to 6, 6 are 36. 36 into 6 is 216. 5 into 5, 25 into 5 is 125. 125 divided by 216. So, in 3 throws, the probability of not getting a doublet is x is equal to 0. That is probability of no doublet. Since there are 3 throws, 5 by 6 into 5 by 6 into 5 by 6. So, that is equal to 125 divided by 216. Now, let us come to the case 2. Probability of 1 doublet and 2 non-doublet. When x is equal to 1, x is equal to 1 in the sense there is 1 doublet and the remaining 2 cases are no doublet. So, 1 doublet and 2 non-doublet. So, 1 doublet, the probability of 1 doublet is 1 by 6 into 2 non-doublets are 5 by 6 into 5 by 6. So, this is nothing but 5 into 5, 25 divided by 6 into 6 into 6 is equal to 216. So, the probability of getting 1 doublet is 25 divided by 216. This is case 2. Okay. Now, in the first case, when x is equal to 0, the probability of no doublet. So, the no doublet means the probability of no doublet is, this is a condition, 5 by 6. So, therefore, we are tossing 3 times. Therefore, here a doublet in the 3 throws. We are using 3 throws for this. No doublet means 5 by 6 into 5 by 6 into 5 by 6 3 times. 5 5s are 25 into 5 is 125 divided by 216. So the first case is 125 divided by 216 for the probability of no doublet. Okay. So that is therefore P of x is equal to 0 is 125 divided by 216. Now let us come to the case 2. When x is equal to 1, probability of x is equal to 1 means one doublet and two non-doublets. One doublet means first maybe the doublet, first row is a doublet, or the second row is a doublet, or the third row is a doublet. So therefore the possibilities are one doublet means it is 1 by 6 and the remaining two are not doublet, 5 by 6 into 5 by 6 plus the first one is not a doublet and the second one is a doublet and again third one is not a doublet plus similarly the first two conditions, first is not a doublet, second is also not a doublet and the last one is a doublet. So you will get 1 by 6 into 5 by 6 into 5 by 6 plus 5 by 6 into 1 by 6 into 5 by 6 plus 5 by 6 into 5 by 6 into 1 by 6. So if you multiply this, 5 5s are 25 divided by 216 plus 5 5s are 25 divided by 216 plus 5 5s are 25 divided by 216. Take LCM 216. 216 is the LCM. 25 plus 25 plus 25. So 25 plus 25 plus 25. This is equal to 75 divided by 216. So therefore the probability distribution when x is equal to 1 is 75 divided by 216. This is the case 2. Okay. When x is equal to 0, probability value is distribution x is equal to P of x is equal to 0 is 125 by 216. P of x is equal to 1 is 75 divided by 216. Now let us come to the case 3. What is this? When x is equal to 2, the probability of two doublets and one non-doublet. Two doublets and one non-doublet. So here also the two doublets means first one is a doublet and second one is also doublet and the third one is not a non-doublet. Plus similarly the first one is a doublet, second one is not a doublet, again third one is a doublet. Plus the condition, the last one is first one is not a non-doublet and the second one is a doublet and third one is also a doublet. So 1 by 6 into 1 by 6 into 5 by 6 plus 1 by 6 into 5 by 6 into 1 by 6 plus 5 by 6 into 1 by 6 into 1 by 6. So this is equal to 5 ones are 5 divided by 6 into 6 into 6 is 216. Again 5 ones are 5 by 216 plus 5 ones are 5 divided by 216. Take LCM 216 is the LCM. 5 plus 5 plus 5. 5 plus 5 plus 5 is 15 divided by 216. Therefore, probability of x is equal to 2 is 15 divided by 216. This is the case 3. Okay. Now, the last. So, I hope you are understanding. So, just listen to me. The probability of x is equal to 2 means probability of two doublets and one no doublet. So, that means two doublets are 1 by 6 into 1 by 6, no doublet is 5 by 6. Plus, similarly, first one is a doublet, second one is not doublet and third row is not a doublet. Plus, similarly, first row is not a doublet, second and third rows are doublets. So, therefore, we are going to get 5 by 216 plus 5 by 216 plus 5 by 216 is equal to 15 divided by 216. So, therefore, probability of x is equal to 2 is 15 divided by 216. Now, let us come to the case 3. What is the case 3? The probability of x is equal to 3 means 3 doublets. All the 3 are doublets. So, the doublets are 1 by 6 into 1 by 6 into 1 by 6. So, this is equal to 1 divided by 6 6 are 36 into 6 is 216. So, therefore, probability of x is equal to 3 is 1 by 216. This is the value when x is equal to 3. So, when x is equal to 3, the probability of getting a doublet is 1 by 6 into 1 by 6 into 1 by 6, that's equal to 1 by 216. Okay. Now, substitute these values in the distribution. Thus, the required probability distribution is, here it is x and P of x when x is equal to 0, when x is equal to 1, and when x is equal to 2 and x is equal to 3. So when x is equal to 0, what we are going to get? 125 by 216. When x is equal to 1, 17 by 216. So 125 divided by 216. When x is equal to 75 divided by 216. When x is equal to 2, when x is equal to 2, it is 15 by 216. When x is equal to 3, this is 1 by 216. So this is the probability distribution for the given problem. The probability distribution table is when x is equal to 0, it is 125 by 216. When x is equal to 1, 75 by 216. When x is equal to 2, 15 by 216. When x is equal to 3, 1 divided by 216. Now suppose if you want to verify, you can verify the sum of these all must be equal to sigma P of x is equal to 1. Let us verify. If you want verification, we can verify. Now let us come to the verification. Verification, sum of the probabilities sigma is equal to 1 to n pi is equal to 125 by 216, 75 by 216, 15 by 216 plus 1 by 216 is equal to 216 divided by 216, that's equal to 1. So therefore sigma I is equal to 1 to n P of I is equal to 1. That's it. Okay. This is how we are going to verify. If it is required, we can verify. Otherwise, no problem. Okay. Now let us come to the next problem. Let us go to the problem number 2. Now come to this problem. This is very important problem. So you may expect this type of question. What is the problem given? Let x denote the number of hours you study. So x denotes the number of hours you study during a randomly selected school day. The probability that x can take the values x as the following form where k is some unknown constant. So what is the condition given? P of x is equal to, when x is equal to 0, P of x is 0.1. When x is equal to 1 or 2, P of x is kx. When x is equal to 3 or 4, P of x is k times 5 minus x. 0 otherwise. Find the value of k. And what is the probability that you study at least 2 hours and exactly 2 hours, at most 2 hours. This is to be determined. Okay. This is very important problem. What is the problem given? Let x denote the number of hours you study during a randomly selected school day. The probability that x can take the values x, small x, as the following form where k is some unknown constant. What is the condition given? The values of x, probability of x is equal to x is 0.1 when if x is equal to 0, k times x if x is equal to 1 or 2, k into 5 minus x if x is equal to 3 or 4, and 0 otherwise. Then in such case, find out the value of k, and also what is the probability that you study at least 2 hours, then exactly 2 hours, at most 2 hours, at least 2 hours, exactly 2 hours, at most 2 hours, that is to be determined. Okay. Now let us come to the solution. Now what is the solution given here? This is given when x is equal to 0, when x is equal to 0, probability of x is equal to 0 is 0.1. This is given. When x is equal to 1 or 2, P of x is equal to kx. When x is equal to 1 or 2, P of x is equal to k into x. So therefore, P of 1 is equal to k into 1 is k, and P of 2 is k into 2. This is equal to 2k. This is given. Again, second condition. When x is equal to 3 or 4, P of x is equal to k into 5 minus x. P of x is equal to k into 5 minus x when x is equal to 3 or 4. So when x is equal to 3, P of 3 is equal to k into 5 minus 3, that is k into 2. This is equal to 2k. When x is equal to 4, P of 4 is equal to k into 5 minus 4, that is k into 1 is equal to k. Okay. And what is the last condition given? 0 otherwise. So it is 0 otherwise. It is not required. 0 otherwise. So therefore, when x is equal to 0, p of x is 0.1. When x is equal to 1, p of x is k, and when x is equal to 2, p of k is 2k, p of 2. When x is equal to k times 5 minus x, that is when x is equal to 3 or 4, p of 3 is 2k and p of 4 is equal to k. Okay. These are the given conditions. Now let us put the probability distribution. So therefore, the probability distribution is x and p of x. So 0, 1, 2, 3 or 4. So when x is equal to 0, p of 0 is 0.1. When x is equal to 1, it is k. When x is equal to 2, it is 2k. K and 2k. When x is equal to 3, it is 2k. When x is equal to 4, it is k. So this is 2k and k. This is the probability distribution. Okay. Now, when x is equal to 0, p of x is 0.1. When x is equal to 1, p of 1 is k. When x is equal to 2, p of 2 is 2k. When x is equal to 3, p of 3 is 2k. When x is equal to 4, p of 4 is equal to k. Now, first find out the first condition. What is the first condition? Find the value of k. Now, A. To find k. Now, to find k, we know this formula. We know that sigma I is equal to 1 to n, p of I is equal to 1. So, this substitute this. That is 0.1 plus k plus 2k plus 2k plus k is equal to 1. So, that is 0.1 plus k plus 2k, 3k, 3 plus 2 is 5 plus 1 is 6k is equal to 1. Now, add this 0.1 plus k plus 2k, 3k, 3 plus 2 is 5 plus 1 is 6k is equal to 1. So, therefore, 6k is equal to 1 minus 0.1. 6k is equal to 1 minus 0.1 is nothing but 0.9. So, therefore, k is equal to 0.9 divided by 6 is nothing but 0.15. So, therefore, the k value is 0.15. The value of k is equal to 0.15. K is equal to 0.15. Okay. Now, let us come to the second case. What is the second case? What is the probability that you study at least 2 hours, exactly 2 hours, at most 2 hours? Now, case 1. Now, let us come to the first one. Probability you study at least 2 hours means that is nothing but probability of x greater than or equal to 2. That is nothing but that is equal to probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is equal to 4. This is the first case. Probability you study at least 2 hours means at least minimum 2 hours. So, probability of x is greater than or equal to 2. At least 2 hours means it is probability of x is greater than or equal to 2. That means at least 2 hours or 3 hours or 4 hours, more than 2 hours. So, x is equal to 2 or more than 2. 2 hours or 3 hours or 4 hours. So, probability of x is equal to 2 plus probability of x is equal to 3 and probability of x is equal to 4. Now, substitute these values from the table. What we have from the table? When x is equal to 2k. When x is equal to 3, it is 2k. When x is equal to 4, it is k. 2k plus 2k, this is 2 times k plus 2k plus k. This is equal to 5 times k. This is equal to 5 into, since the value of k is equal to 0.15. 0.15. So, 5 into 0.15, that's equal to 0.75. The required probability is 0.75. Okay, this is the first case. Now, case number 2, second one. Probability you study exactly 2 hours. Exactly 2 hours means probability of x is equal to 2. That's all. Probability of x is equal to 2 means that is nothing but probability of x is equal to 2. Probability of x is equal to 2 means probability of 2. What is the probability of 2? We have 2k. This is 2 into, since k is equal to 0 0.15, 0 0.15 into 2 is nothing but 0.3. So this is equal to 0.3. The probability exactly you study is 0.3. This is the case 2. Okay. Now the third case is probability of you study at most 2 hours. At most 2 hours. At most hours means probability of x is less than or equal to 2. That means that's equal to probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2. X is equal to 0, x is equal to 1 and x is equal to 2. So when x is equal to 0, it is 0 0.1. X is equal to 1, what we got from the table? X is equal to 1 is k, x is equal to 2 is 2k. K plus 2k. This is equal to 0 0.1 plus 3k. This is equal to 0 0.1 plus 3 into 0 0.15. So this is 0 0.1 plus 0 0.15 into 3 is 0 0.45. 1 plus 0 0.45. This is equal to 0 0.55. The probability is 0 0.55. That's it. So here it is. The third case is 0 0.1 plus 3 into 0 0.15. 0 0.1 plus 0 0.45 is equal to 0 0.55. This is the required answer. So you study at least 2 hours means probability of x is greater than or equal to 2. That is probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is equal to 4. So the answers are 2k plus 2k plus k, 5k. Substitute the value of k. Since k is equal to 0 0.15, 5 into 0 0.15 is 0 0.75. Now probability you study exactly 2 hours means probability of x is equal to 2. That is probability of x is equal to 2 means p of 2 is 2k. 2k means 2 into k value is 0 0.15 is 0.3. Now you study probability you study at most 2 hours. At most 2 hours means probability of x is less than or equal to 2. X is less than or equal to 2 means x is equal to 0 plus x is equal to 1 plus x is equal to 2. Probability of x is 0 is 0.1. Probability of x is equal to 1 is k and probability of x is equal to 2 is 2k. 0.1 plus k plus 2k is 0.1 plus 3k. 0.1 plus 3 into k value is 0.15. 0.1 plus 0.45 is equal to 0.55. So this is the required problem. So for the first case it is 0.75. For the second case it is 0.3 and for the third case it is 0.55. This is very important problem for 5 marks. Hope you followed this. Right. Now let us come to the next problem. An iron contains 5 red and 2 black balls. 5 red and 2. 5 red plus 2 black balls, totally 7 balls are there. So 2 balls are randomly drawn. Let x represent the number of black balls. What are the possible values of x? Is x a random variable? We have to find out what are the possible values of x. What is x here? X represents the number of black balls. So what are the possibilities of drawing a black ball? And if x is x a random variable, drawing a black ball is a random variable or not, that is to be determined. Very simple and important problem. An iron containing 5 red and 2 black balls. Let us represent the red balls as R and the black balls as B, capital B. So therefore the red as capital R and the black as capital B. Okay, R and B represents the red and black balls. So totally there are 5 red plus 2 black balls, total is 7 balls. Let X represents the number of black balls. B, what are the possible values of X? Drawing a black ball. Is X a random variable? Now, let us come to the solution. Given urn contains 5 red and 2 black balls, 5 red and 2 black balls. So let R represent the red ball and B represent the black ball. So 2 balls are drawn randomly. Hence the sample space, 2 balls we are going to draw. The sample space will be, first will be the black and the second ball will be the red. First ball will be the red and the second will be the black, and the last condition is both the black balls you may get. So therefore the sample space S is equal to black ball and black ball, both are black. First one is black and second one is red, B and R. First one is red and second one is black, R and B, and both the balls are black and black. So B, R and R. So first one is B and B and the last one is R and R, B, R and RB. So the sample space is black and black, black and red, red and black, and R and R. So the number of events N of S is equal to 4. Okay. Now what is given? Since X represents the number of black balls. Okay. Now since X represents number of black balls, therefore the probability X of B and B, how many black balls? So the possibility of getting a black and ball is 1 plus 1 is equal to 2. So first one is a black and second one is a black. So 1 plus first and second 2. Now X of B and R, first one may be a black ball and the second one may not be a black ball. So 1 plus 0 is equal to 1. Thus condition third one, X of R into B. The first one is a red ball and the second one is a black. 0 plus 1 is equal to 1. And the fourth condition, both the balls are red, means it is 0 plus 0 is equal to 0. Okay. So let X represent number of black balls. So therefore X of B and B, first one is black, second one is black. 1 plus 1 is, there are two possibilities. X B of R, first one is black and second one is red. 1 plus 0 is 1. Again X red ball and the black ball is 0 plus 1 is equal to 1, and red and red both are 0. 0 plus 0 is equal to 0. Therefore X is a function of the sample space whose range is 0, 1 and 2. X is a function of the sample space whose range is 0, 1 and 2. Thus X is a random variables which can take the values 1, 0, 1 or 2. So hence the required answer is, therefore X is a function of sample space whose range is 0, 1, 2. And the second answer is, thus X is a random variable which can take the values 0, 1 or 2. This is the required answer. Okay, that's it. Let us meet with a different concept in the next class. Thank you. Thank you very much.